Hey everyone, Matheus here. I'm going to talk to you a little bit about PTLCs, MRTREEs, and offline lightning payments, something I've been working on and off for a couple of weeks, a few weeks now, and that I want to show you is a really cool and interesting thing development on the Grids Lightning Network. So PTLCs, just a quick recap on PTLCs. PTLCs are a new designed way or a new feature for Lightning that aims to change the way payments are bound in the Lightning Network. So instead of using a standard hash challenge to lock the funds, we use a public point to lock the funds. And during the review stage of the payment, instead of revealing the pre-image to some hash number, we reveal the secret scalar or the private key to some public point by way of using adapter signatures. So this is a very interesting development that is being talked about and being designed and being worked on in the Lightning Network. The way to bind payments to PTLCs in the Lightning Network, this is a channel state diagram for Lightning Network. We have Alice's commitment transaction, Bob's commitment transaction, and we're showing here a single HTLC offered by Alice and accepted by Bob. And this is the standard HTLC binding process where if Alice publishes her commitment transaction, Bob can redeem by revealing the pre-image. And if Bob broadcasts his commitment transaction, Alice can still find out the pre-image because Bob is still going to reveal the pre-image via the success transaction. And so the main challenge one of the main challenges to move into PTLCs is ensuring that Alice can find out the secret scalar, or in other words, ensuring that Alice has an adapter signature which can only be completed by adding the secret scalar. So in the same way that in the HTLC world, Bob can only redeem the funds in this output by revealing the pre-image, we want in PTLCs an output that can only be redeemed by revealing the secret scalar. First attempt to try and implement this in the most naive way is to have to switch out from the standard of SHA-256 or people verify encumbrance in the PTLC output to object sig or object schnorr sig or object sig out in case of Tigray to bind the payment to a specific adapter signature and corresponding secret scalar. However, that doesn't work out because when Bob is signing Alice's commitment signature, which is case A in the channel state diagram, when Bob is signing Alice's commitment signature, Bob is the one creating the adapter signature. And therefore, Bob has pretty much freedom to pick, to design this adapter signature in any way such that he doesn't necessarily reveal the secret scalar. And so the standard way of, or the most straightforward way of trying to bring PTLCs fails because of this problem. And so we want to have some way, what we want to do is bind Bob's full Schnorr signature such that Alice, upon seeing the adapter signature, can figure out the secret target scalar once she sees on chain Bob's full signature. So we want Bob to send out a full Schnorr signature on chain, and we want to have Alice having seen the adapter signature to be able to figure out the secret scalar. So the main challenge that we are trying to answer here is to prevent Bob from selecting a different valid U plus T, that is a different valid nonce point, once he has shown Alice his partial signature. So one trick that I figured out on how to do this is by using opcat. And so instead of binding in case A, instead of simply binding the payment to Bob's adapter signature, we bind the PTLC script to a specific R point, which is the sum of the secret nonce that we are interested in, and in a random nonce that Bob generates, such that Bob cannot later change this point, and thus select a different secret scalar or different scalar, and Alice can figure out the actual target secret scalar. So we're going to use opcat to bind the payment on the commitment signed message. And so to get a single round trustless PTLC, we establish a new transaction here in Alice's commitment transaction. We're going to create a new transaction, which I'm calling the PTLC success no delay transaction. The signature for this transaction is going to come from Bob, and it's going to be an adapter signature. And so Bob is going to send an adapter signature for this transaction to Alice. And then once Alice broadcasts her commitment transaction and Bob redeems this transaction here, Bob is going to be forced to reveal the secret scalar to Alice. And we are doing this specifically by, in the sender PTLC script, binding Bob to a preset R point in the PTLC script. So Bob has doesn't have freedom after generating this R point and after sending Alice her commitment signed message. Bob doesn't have freedom anymore to change this R point. And so to redeem, Bob is going to be forced to simply send the S component of the Schnorr signature, and the S component and the R component are going to be concatenated into a full Schnorr signature and then verified in the standard way. And so we can force Bob to not be able to change his R point. This has a couple of downsides, so this is still a largish script. I haven't collapsed all these conditions into a single check sig operation. There needs to be some Bob needs to be careful in selecting the nonce, because he needs to both be able to redeem this in the future, but he needs to be careful not to reveal his private key. So there's some security needed when selecting the R point. And another downside is that Alice cannot create her commitment transaction before seeing Bob's commitment sign message, because we are binding the signature, the R point, directly in the sender PTL script. So Alice can't create the script before being given the R points by Bob during the commitment sign step of the channel update protocol. So some cool stuff that you can build once you have PTLCs. There are a bunch of applications already discussed. One new application that I'm going to discuss here is implementing multi-redeemer transaction trees with PTLCs. So the Mr. Tree transaction construct I discussed some time ago because it relates to multi-owner tickets, Lightning Network-based multi-owner tickets. And so the Mr. Tree construct is basically a tree of transactions, a binary tree of transactions that users can join by by building this whole construct, this whole tree of transactions offline or off-chain, and then signing and having this entire thing be a valid construct, then atomically swapping funds with an on-chain provider of funds. So the provider here, this P star here, has some on-chain funds. A bunch of users have off-chain funds that they want to swap for with the provider. And so they do sort of a submarine swap here, where they end up with a single on-chain output, but an entire tree of transactions off-chain. Pre-signed, but off-chain. So once the users have joined the Mr. Tree constructs or a specific Mr. Tree construct, they can redeem back leaf outputs by presenting a leaf key to the provider. So they do a PTLC payment. Initially, to join the Mr. Tree, the users are paying the provider for funds. And then when they want to redeem leaf transactions, the provider is going to pay back off-chain to the users, and the users are going to review on each payment one specific leaf key to the provider. The important feature of this construct is that by revealing these leaf keys to the provider can rewrite sub-branches up to the root transaction or the root output of the Mr. Tree. By discovering these leaf transactions, the provider can use a specific redeeming condition in the Mr. Tree script that allows it to redeem the transaction without a time lock. So this entire thing, this entire tree of transactions has an initial time lock of some blocks. And then if the provider finds out all the leaf keys, they can redeem immediately. And if they only find out some subset of the keys, they can redeem only that subset of transactions as a single output. Each leaf has two keys, user and provider, and each intermediate key is the sum of the child keys for that particular branch of the Mr. Tree. And so by finding out every key, every leaf key, the provider can rewrite in a single output that in a single transaction that output. So this is safe both for users which don't have to, due to the initial time lock, don't need to have a watchtower. They don't need to keep watching the chain to see if the Mr. Tree has been redeemed. They can just check after the initial time lock, which can be arbitrarily long. So you can have a Mr. Tree that has for example, a 1 year initial time lock or a 6 month initial time lock. And this preserves the user's exit rights, because if the provider disappears after the initial time lock, they can redeem their funds. And this is safe for the provider because if some users fail to redeem their funds, the provider can simply redeem the funds for the branches that cooperating users have sent their keys. So this entire thing is smooth to be safe and based on PTLCs and entirely working through PTLCs. So a sample application that we can show using MR-TREE are offline lightning donations. So the basic workflow for offline lightning donations using the MR-TREE, using a MR-TREE construction, is by having Alice join a long-lived MR-TREE construct, possibly along with other users. After building out this tree and having the funding transaction confirmed, Alice can go offline for quite some time. She doesn't need to participate anymore in the MR-TREE. But if she wants to donate some funds to Theo, she can send a leaf key to Theo, a third party, via whatever communication method she wants. She can send the key via chat or email or whatever. And Theo can then redeem his the funds for that corresponding key without having initially participated in the MR-TREE transaction. So Alice builds out the MR-TREE with a provider, sends a key to a third party, to Theo. Theo can then contact the provider and fetch the funds off chain. So this is effectively, and Alice doesn't need to be online for this step. So we can perform an offline lightning payment or an offline lightning donation by using the provider and using MR-TREE transaction. So I'm going to now test it up. Okay, so I'm now going to try and demonstrate the MR-TREE construct running in the Crediton with a sample application for offline payments, offline lightning payments. Okay, so I have two wallets here, Alice and Theo. I'm going to start up Alice. I'm going to connect Alice to the Lightning Network. Okay, so Alice has one open channel into the larger network, and I'm now going to have Alice join a MR-TREE construct. Okay, so let me just run the MR-TREE server here. There's a bunch of things that are hard coded, so since this is just a proof of concept, I don't have session discovery, so I'm just creating a sample session here in Synnet. So Alice is going to join this MR-TREE session, and this session is built. Okay, and if I look here in payments, Alice has just sent a payment for the MR-TREE construct. These are the three transactions, the signed three transactions. These transactions are signed specifically on their locked redeem branch. So if I, for example, try to send this transaction to the network, it's not going to accept because the sequence lock on the input isn't yet resolved. So for example, let me change the FTX. So let me, sorry. If I decode this transaction right here, you can see it has a sequence number. It's pointing to the previous output, which is the MR-TREE funding transaction. And I can mine this transaction right here. Let me just double check. This transaction is mined yet, but I can easily mine it. There we go. One confirmation. And so the Mr. Tree root transaction is now confirmed. And I can now, Alice can now participate. So the root transaction has a long time lock until it can be redeemed by the pre-signed transactions. However, I'm going to just quickly copy these out. So this is the session token, which identifies the specific tree that was built on the server. And these are the leaf keys that Alice used to, these are the leaf keys that Alice used to join the Mr. Tree transaction. So for example, Alice can redeem one of them. So let me just quickly demonstrate Alice redeeming. And what redeeming implies on what redeeming a Mr. Tree transaction implies is that it's Alice is creating an invoice and the provider is settling this invoice. And now the provider has figured out, I can see Mr. Tree leave transaction just now. What's happened here is that the provider has discovered this leaf key right here. And the interesting thing about the Mr. Tree construct is that I can have a third party. So I'm going to close Alice. Alice is now disconnected to the Lightning Network. It's offline. I'm going to launch a second node, second Theo node. Sorry. Let me have Theo connect to the Lightning Network as well. Okay, so Theo is connected to the Lightning Network. Theo has not joined that Mr. Tree transaction. However, if Alice, for example, sends an email telling Theo, hey, you can redeem some points by contacting the provider and passing him this leaf key right here, Theo has now received some Lightning Network funds, some funds on the Lightning Network, just by providing this leaf key to the provider. So we've effectively done an offline Lightning payment by using a provider, by using the Mr. Tree construct and the provider as a sort of staging area for Alice's funds. And so now what can happen, what's interesting here is that I can now redeem all the keys. So I'm just going to redeem all keys here. I'm just having Theo redeem all keys, but this could be done by multiple parties. Could be done by Alice if she intends to close out her Mr. Tree position. And now what happens is that the server, the provider, has found all the keys to the Mr. Tree transaction, to the Mr. Tree construct. And so it has sent a redeemed transaction that is not encumbered by a sequence lock. So this transaction, which is spending from the same funds that were pre-signed, however, since this doesn't have a sequence lock, can be immediately mind broadcast and immediately mind. So there you go. And now the provider has fetched back all the funds that it initially used to build out the Mr. Tree. So on chain, this looks like a single transaction, a single transaction involving a single address. It has a very small on-chain footprint. However, it preserves the exit rights for the participants if the provider, for example, disappears, or if the participants only redeem a certain part of the tree, as we've seen. As we've seen on the previous slide here. If the provider disappears, the users can still send out the Mr. Tree set of transactions and redeem their funds. And if one of the users or if many users don't redeem back their on-chain funds, their off-chain funds, or don't redeem their funds in the off-chain Lightning Network, the provider can still redeem back the partial funds that the other users have redeemed. And so this is one of the interesting things that we can do with PTLCs and the Mr. Tree construction, which is one of the bases for one of the basic building blocks needed for multi-owner tickets or Lightning-based multi-owner tickets for Decred. Hope you guys have enjoyed. It took a little bit longer for me to write this than I hoped to take it. I expected, I wanted to have released this at the end of 2020, but unfortunately 2020 was a peculiar year. So, but that's it. So hopefully we can have multi-owner tickets in a few more. I'm not going to say in a few more months, but hopefully soon enough. Thank you guys.